So I'll go ahead and mention, while we're just almost ready to start talking here, that as you may have noticed, we've got a very hardworking gentleman back there that has been taping all the lectures here. They're available for sale in the vendor area. If there's a talk you really like, you want to take it home, show friends, coworkers, etc., or if there's just two really good talks, set up one against the other. You can sit in one room, watch one, buy the other one, and they're available relatively soon after the talk because he's burning them out like crazy. So if you want the talks, you can pick them up in the vendor room. He's got a special, I think they're $20 a pop, and then if you buy 7 or more, it drops down to 15 a pop. So volume discounting. And if you decide further down the line also that you want to pick up the entire set of Toorcon talks, you can do that. He's got the contact information for it. So it's definitely a good resource.
And hopefully they'll be available for download on Google in a couple months, like pay-per-view on Google.
Cool. So we do have the T-shirts available for those of you that didn't pre-reg. The T-shirts are available at what used to be the registration desk for sale. They're $20 a pop. So if you want to get one, go ahead and hurry and do so because we only have a limited number of them in their respective sizes. And I think in terms of announcements, that's pretty much it for the time being. So without further ado, we actually have JaredDeMott up here. He's got 6 years of experience in fuzzing. He's going to be talking on fuzzing, presenting on that, and he just mentioned that he's a student, employee, husband, father, and in his spare time finds a little bit of time left to do some fuzzing work. So please give him a big round of applause.
Thank you. All right, thanks. Appreciate that. See if I can get the slides to come up. There we go. This laptop is old and slow, but it works great for cons when you aren't sure what kind of environment the laptop's going to be in. So I am JaredDeMott. I'm a vulnerability researcher, and I've been fuzzing for a long time, so I'm just going to jump right into it. Since we started a little late, I'll try to end on time. I don't know if that'll happen. Probably not. But so we're going to, this is sort of just a quick agenda. Who fuzzes, why they fuzz, you know, what people think of that word a lot differently. We'll talk about that. What's the state of fuzzers? What kind of fuzzers out there? You know, what do they look like for different people? And we'll talk in depth. I probably won't talk too much about the grammar fuzzers. I don't know if we'll have time for that. I'll talk a little more about generic fuzzers since that's the tool I wrote called GPF. I'll play a little flash demo at the end of the tool. I wrote a demo, so if you guys want to like move toward the screen so you can actually see, go ahead and do that now or whatever, since I'll play it at the end. I don't know if you'll be able to see it way in the back, but and then we'll talk about how web and file fuzzing might be a little different, and some fuzzing metrics, and kind of what I'm doing for research this year, and how we might advance the date. So there was a guy at Microsoft named Peter Olhart who I had emailed a few times and talked to on the phone one time, and I guess he quit Microsoft. But he came up with a definition. He wrote a good paper that I liked a lot. He said, fuzzing is a highly automated testing technique that covers numerous boundary cases using invalid data from files, network protocols, APIs, as application input to better ensure the absence of exploitable vulnerabilities. And the word fuzzing came from Barton Miller in 1990. He published the first work on fuzzing from modem applications' tendency to fail due to random input caused by line noise on fuzzy telephone lines. So he was working in Wisconsin, this guy named Barton Miller, and he was dialed in, kind of a typical Midwest thunderstorm, and he did like LS and it core dumped on his Unix system. He was like, that's really weird. Like, I could see how maybe it'd say like file not found or like error or something like that, but like LS is it's a core Unix utility. It should never core dump. So he started doing some investigating and started looking at that and realized that sending completely random crap to an application was actually kind of a good thing to do. And we'll talk a little more about that and how both software has gotten better since then and both fuzzing has gotten better since then. So we'll talk about that. So that definition is a little big. I like to just say something you can remember and tell your friends. Fuzzing is just automated testing technique to find bugs in software. So testing, bugs, software, that's fuzzing. It's pretty simple. You could do it in hardware. I guess people have done stuff like that, but I don't do that. So one of the things I like to do when I give a talk is just give a quick, just real, like an example at the beginning so everybody's on the same page. Some of you have probably fuzzed. We've got a Mozilla fuzzer up here up front, and probably some of you have never heard of the word, so everybody's on kind of a different page. So I like to use, and I'll use throughout this talk, the example of this cheesy little protocol like FTP, not because is the only thing you can fuzz, but simply because it's a protocol everyone, I think, kind of understands in their mind. They can sort of see this user, Jared, okay, send me your password, my lame password, okay, you're logged in, command. Just something simple so that we can all kind of think of the same thing. How would we fuzz that? Well, maybe you send in between the S and the E, maybe you insert 50,000 FFs or something like that, right? You could do that. And there's a lot of different ways to fuzz, and we'll talk about that structure, random, and it actually might be better to put it in where the Jared is. Why? Because the user's a command, and the argument to that command is Jared. So it's more likely that the Jared will get consumed by some function that might do something naughty with it, right? So in the second one, you see I have 12% ends in the Jared. Anybody know why? Why would we put percent ends? Who knows? Yeah, right. You might be looking for format bugs, right? That's a good, what we call attack heuristic. And heuristic, if I use some term that sounds cheesy and academic, is just what? Rule of thumb, right? It just means that it's either worked in the past, maybe it'll work in the future, so it's just a heuristic. Go ahead.
Percent n is particularly weird. Most things we constantly print up, like percent s, means read this thing as a string, read this as an integer. Percent n means put some data in the, treat it as a pointer and write some data.
That's right. I'd give you a prize, but I haven't got any. So, somebody have a prize for him? Yeah, that's right. So percent ends is better, and that's why I use percent ends when I fuzz, because it's better than using percent x's. Or I actually like to randomize what letter, because you never know. Maybe a percent x does something, a percent n might not. But typically, percent end's the best thing to use when you're looking for format bugs. And also, you see on that same line, I use some random binary data in the third leg of that protocol. So some people believe when you're fuzzing, maybe you should only ever have like one fault session. Well, I've found that sometimes 2 faults per session or something like that could be interesting, right? If you have multi-session bugs, or you're looking for a second-gen bug like an uninitialized variable or uninitialized stack. I'll talk a little bit about that later. Again, there's just a lot of different ways, and this is just an example. Maybe you put a bunch of nulls, maybe just some random junk at the end. Okay, so what are some other terms you may have heard that are also fuzzing? You may have heard the term monkey, stochastic, stress testing, all these different things. They're either the same or not, depending on who you talk to. So I'm just going to use the word fuzzing. And in quality assurance, a lot of times they use a term called negative testing or robustness testing, right? And we'll talk a little bit about how the QA world's been different. So software testing, what is this whole thing again, right? Well, it's tough. For one thing, software testing is not. So it's hard to just like say this company put out crappy software. They may very well have, but it's very difficult. It's very expensive. It's very time consuming, and it doesn't give you any guarantees, right? There's no mathematical proof at the end that, well, we tested and didn't find any bugs. That's great, but there still could be some, right? So, but it's the only method we have to gain any confidence or assurance that our software does, in fact, do what we think it does. So you have to do it. Now, the 2 main types of testing out there are and static, right? You guys probably know some of this, but I'm kind of just hitting all the highlights of this whole little field real quick at the beginning, just so you can sort of see how fuzzing fits into this. Dynamic is like you actually took a program, you compiled it for Windows, you compiled it for SCO Unix, whatever, and then you actually tested it on that box, because it could be different, right? Same code base, you know, maybe it doesn't have bugs in Linux, but maybe when you compile it for Windows, there's a race condition or something, right? So it's good to do dynamic testing. It's tough, because it's the same sort of problem. You're sending data, and you don't really know if the data is the right data, or if you send it at the right speed, or the right time, or with the right variables, or on the right hardware. Anybody tests something and it works fine, and then you test it on a dual core box, dual processor box, and you realize you got race conditions up the wazoo. So there can be things like that are really tough to find until you've tested a lot. Structural testing or static testing is like I have the source code, and I'm going to maybe buy some fancy commercial tool, like a and I look through for naughty functions like stir copy, or maybe I look for uninitialized variables or whatever. Also a good thing to do. So you want to do both, and typically I think consultants who do this kind of work, they're looking for bugs for a living for clients, or maybe they just do it on their own in open source software, or whatever they do, right? If they're a hacker or whatever. You kind of want to do both these things. So how does fuzzing fit into the formal methods of software engineering, software quality assurance? Then you have a group, software testing. Fuzzing is just a piece of that, okay? And it's typically, if you really want to harness the power of fuzzing, you're going to do some gray box stuff, and we'll talk about that. There's other stuff. There's unit, there's integration, there's system, there's end-to-end, there's functionality, and all that still needs to happen. And so some people have asked me, like, oh, fuzzing. Yeah, I heard about this new thing called fuzzing, and it rocks. It's like the newest thing. Well, not really. It's been around for a while. Testing has been like, you create a gun in like 1910, you got to go shoot it to see if it works right. So the idea of testing is not new. This idea of fuzzing in some ways is not new. But how it's been applied is fairly unique. We'll talk a little bit about that. So fuzzing, I don't have to reverse engineer anything anymore now, right? Because I fuzz. Wrong. Right? So it doesn't replace anything. It sort of supplements and it complements. You still reverse engineer. You still do functional testing and all these other we always did. You still want to do that. And it may not be usable for everything in every case, right? If you've got some funny Java applet running in a web service or something like that, it might be kind of hard to fuzz certain things. You could still fuzz it, I'm sure, but I'm just saying, like, traditionally, like if you have a daemon or a client written in C, I mean, you want to fuzz that thing, right? Because you're going to find some buffer overflows or something like that. But maybe if it was written in some other language or some other platform, it might not yield as much fruit effort. So there's always sort of that ratio, right, of sort of investment versus payoff kind of thing. So how good are they? Well, since Miller in 1990 found that half of all Unix core utilities died when they were delivered random crap, that's pretty effective. To right now, to guys like H.D. Moore and myself and a guy named Martin Vagneau has done some good work on a tool he wrote called AutoDefA. It's good, some good stuff. It's working, and it's still very effective, and it's still a good way to test. So there's some people doing some research on that now and probably for a long time to come. So who builds them? Software companies now do it. Even though it's been around for a while, probably just within the last, say, 2 years or something like that, big companies like Microsoft, they fuzz the crap out of everything. Nothing leaves the doors at Microsoft unless it's been fuzzed now. And vulnerability analysts have been doing it longer than 2 years. Fuzzing companies, they write fuzzers and they sell them, right? You can pay a lot of money for fuzzers. So talking with a guy named Ari from Finland, who was part of a company called Codenomicon. I don't know if any of you guys have ever heard of him, but they sell fuzzers, and we're thinking about writing a book together, which should be kind of cool because their approach to fuzzing is a lot different than the way I approach fuzzing, so it might be kind of a good mix to see how that's done. But I know there's a lot of other companies out there selling fuzzers. I give my fuzzer away. I don't academia, hackers, whatever. So they're used because they work, and it's really hard. Like when Miller released his academic paper in 1990, he got no love from the academic community at all. It was kind of like, wow, you gave random crap, and it broke stuff. Big freaking deal. There's like no NP complete, like there's no algorithm that goes along with that or anything like that, right? There's nothing computer science-y about delivering random crap. So he didn't get any love, and it really didn't go anywhere for a while after that at all. But he did it again, I think in 95 and again in 2000, and every time he did it, he kept finding bugs, and I think the academic community was pretty unimpressed every time he did it. But the security community jumped on that, and I think was able to do something with that the testing community wasn't able to do. See, QA and testers, they've got, I'm not actually a professional tester, so I don't really know all the terms and processes and terminology, but they have a lot of special ways of categorizing bugs and lists and retest and formal ways of doing this. But then, the security community kind of came along and said something to the effect of, I found a bug too, and I can root your box with it, something like that. So it's kind of like, whoa, holy crap, that's a good thing to do. We should fuzz. So it got a little more attention, I guess, as some things like that. So what do fuzzers do? The heart and soul of a fuzzer is basically this. You have some data, right? Some source data, and I got the fuzz function around it, right? Because it's pretty, you want to do something to that data. And the word that gets used is semi-valid or semi-invalid. And there's a reason that word gets used, okay? And that reason is kind of like Dan Kaminsky was talking about. He used the word dumb and smart. You guys were there at that talk when he used the word dumb, fuzzers, and smart? I don't really like those words, and I'll talk about that in a minute. But the whole idea is you don't want everything you deliver to be crap, all right? the process that gets all this crappy stuff will probably just kick it out. Like in that cheesy example I gave with the FTP type protocol, if there's not user space something, likely the first thing the server will do is reject everything after that, right? Because it didn't conform to the protocol. So there needs to be some conformance in there. So it needs to be semi-valid, which means the rate of errors needs to be fairly low, okay? So you have that function, however you're going to fuzz. We'll talk about different ways to do that, and those are attack heuristics. Essentially, it's a good word to use. Looking for, buffer overflows, putting in long strings, or format bugs, or out of order commands, or multiple commands on one line. What if you did pass space user space pass space user, and some crap, and no carriage return line feed at the end? What would it do with that? I don't know. You got to test it, right? So fuzzers should be able to do that kind of stuff. And what are we fuzzing? We're fuzzing the attack surface, and that's simply some subset all the code, right? Because you have all this code. Again, if we use our FTP server example, you have the code that reads in the configuration file, the UI code for the administrator to click buttons and stuff like that. You're not fuzzing that, right? If you're on UDP or TCP or whatever, you're fuzzing the network interface, which is the attack surface, and that's really the code that we're interested in, okay? And there's been some work done to try and figure out what that code is, the attack surface. Can you strip out the rest? Can we just do, code coverage metrics on that piece or something like that? That's what you really are interested in, right? Because if that's the part of the code that consumes your data. If it doesn't consume your data, you're not really interested in it, because you're not going to be able to break code that doesn't consume your data. So unlikely. The other piece, and this is sort of I don't know why, but in the past it's kind of been like the redheaded stepchild of fuzzing. It's sort of like the process monitoring, right? You have the funky data creation on one hand, and you have the process monitoring on the other hand. In other words, you need to figure out when it happened. And there's a lot of ways you could do that. The best way is basically use a debugger. I've been using the PyMay framework that Pedram came up with on Windows a little bit lately, and that's a cool way to do it. You basically just tell it hey, I'm going to start this process, right now. Especially really useful if you're fuzzing clients, because you can start, the server in a fuzzing mode, and you can start up a client and say, try to, consume this document, or try and consume this session or whatever. If you haven't got a memory access violation in, say, 10 seconds, go bye-bye, and I'll start up another client, right? Because otherwise you'd have to click, 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 right, or something like that if you were client fuzzing. So you need some way to kind of, learn how to automate that and to monitor that. There is one little snafu with using a debugger, and that's this. The most recent sendmail bug, this is my understanding of it. It was a race condition, and if you actually started sendmail in a debugger and then you tried to fuzz it, you wouldn't find the bug because it changed the characteristics of the race condition such that you hit on it. And that's just really ugly, because that sort of screws up everything we're trying to do. So if you're really paranoid and you think maybe you're trying to find some really obscure bug and you don't even want to start it in debugger because you're so paranoid, probably you can monitor it some other way. If you start the process, before you start the process, maybe do something like a ulimit-c unlimited in Linux or something like that, so maybe it'll core dump. Okay, you can analyze the core dump, or maybe maybe it writes messages, to var log, mail log, or something like that. Maybe you can grep those messages while it's running and see, oh crap, the process just got a segv or something like that. And if you're not familiar with those terms I'm talking about memory access violation. You guys probably all know what that is. It's or a core dump, or a seg fault, or a segv. It's just inside the process, it tries to access some memory other than what it's allowed to. I'm sure you guys know that, but I just want to make sure we're all. So why do fuzzers work? They have a general goal to break software, and this is where I think security testers in recent years have done a good job of sort of pushing, or raising the flag of fuzzing and stuff like that. Is sort of they weren't just doing functionality testing. They weren't just doing user testing and all this stuff on the software. They were somebody else might be I want to make sure that this program works right. And I'm kind of I don't even know what this program does, and I don't even care. All I want to do is see if I can get it to do a memory access violation or something like that when I fuzz it, right? And you can actually do that. And I'll show you at the end. I'm going to, like I said, run a video of a tool where I wrote. You can actually capture a session of some data, replay it with faults and fuzzes injected. You may not even know what that protocol is or what that process is, right? I mean, ideally you do, because like anything else, the more you know about it, the more likely you are to actually do something useful. But it's possible you could find a buffer overflow or a bug like that, and you don't even understand what the process you're fuzzing is or does. And that's a pretty cool thing that I think some of the vulnerability researchers brought to the table. It's sort of want to know too much about this process, right? Because then I make assumptions that may not be good. So code coverage is a really interesting metric. It's like a two-edged sword, because if you have not covered code in your attack surface, then you have not looked for bugs and you will not find bugs. So what testers did initially, and I think this is where they kind of went wrong with some of the testing that they did, is sort of like, well, my boss told me I have an 80% code coverage target. I'm going to write a suite of tests that will achieve coverage of 80%. I check and I go home and everybody's happy because it doesn't find bugs probably. But the problem was that that's the whole goal of their tool. The goal of their tool was to get code coverage. And so what happens when you make something your goal? You're probably going to achieve it. They achieved their goal, but they didn't find any bugs because, you know, take for example an if-else statement. They wanted to create a test that would hit the if and then the else. Well, but they didn't hit the else with 10,000 bytes, and they didn't hit the if with a format string. You know what I mean? Like, they didn't hit it with the right data. So the idea of hitting all pass with all data is what you want. Unfortunately, that's an infinite problem. That's an NP hard problem. So that's where heuristics and things like that come in to make the runtime more feasible. There's also this notion of gap coverage, which is sort of like saying something like, maybe you're this like Uber fuzzing company, and you come up with a test suite or a fuzzing tool or something like that, and it found 700 bugs in this product, and it rocks. And then I came up with this crappy, lame fuzzer that just blows, and I found one bug. But that's still significant, right? Especially if that one bug is like a remote vulnerability exploit or something like that, right? So the idea of gap coverage is that no matter how thoroughly you test, you still really don't have 100% assurance that there's no bugs. And somebody else could write a lame tool that's different in some way that could potentially find something that yours didn't. So what kind of fuzzers are there? What do people use when they fuzz, right? Well, it depends a lot on the situation, right? If you're file fuzzing, or if you're going after websites, or if you're going after, say you have some library, you've got some code, and it's not even really compiled into a binary or something like that, so it doesn't have a network interface or something like that. You might, you know, you're going to have to test differently depending on what your situations are and stuff like that. But in general, a lot of times we want to fuzz stuff that has a network interface, because why? Well, if it doesn't, you can't reach it remotely, so it's less interesting. So there are some assumptions you can make that are fair under some circumstances like that, and I do that. My tool only fuzzes things with a network interface because that's all I cared about. So two different kinds of fuzzers that are probably the most prevalent is, like, one's called generation, and this is what Ari's company, Codinamicon, does. They basically say, look, we're going to create one fuzzer for everything we're going to fuzz. If we're going to fuzz, you know, whatever, VoIP or HTTP or FTP or whatever, we'll create a fuzzer for each one, and we'll completely implement the RFC, even the extended options and everything like that, and we'll get a thorough test. And they're good tools. Like, you run it, and it tests it tests it pretty well. I like it. And they have a list of tests, and it runs the same way every time. It's deterministic in how it runs. Okay, so the other approach, and this is the approach I've taken in my work, and this is like mutation or capture replay. It's sort of like, let me start Ethereal or Wireshark or TCP dump or whatever you use, something that gives you a PCAP file. That's all my tool requires. And let me just capture a session, and then let me replay it. And we can do that in a lot of ways. We can just like replay it to it replays right, or we can replay it, you know, so that we only put a buffer overflow in the third leg of the protocol, or we can set it to like pattern fuzz, which is the one I use most often, which is sort of like it'll try and understand the protocol best it can, like especially if it's a text protocol, it'll like basically auto detect the pattern, because all text protocols follow a pretty deterministic pattern, like, you know, like a lot of the ones like SMTP and HTTP and FTP and Nmap and all, or Nmap, IMAP, I'm sorry, stuff like that. They all sort of follow the sort of like, you know, something space something carriage return line feed. It's a pretty simple pattern, actually. So it knows something about that. It can say, well, you want to fuzz the space differently than the variables, when you want to fuzz the, you know, the line ending differently than you would the variables. So you can make some assumptions that are pretty solid about that. When you go to fuzz a binary protocol like DNS, that's something like session ID, flags, length, you know, string, the length defined string, you got to do something different, right? Because if the length of the string, you put 5,000 bytes in the string, now the length isn't right, you need to fix that up. It's kind of basic fuzzing, sort of 101. But it needs to be able to handle that, and you can do that by writing, I call it a tokenizer in mine. You just give it some knowledge, some plug-in of how that binary protocol works, and then it can replay that successfully. So now there's cons to that, right? Because if you do a capture and then you just replay that, well, the chance that you captured a complete, RFC compliant spec of that protocol is fairly slim, right? Because you probably didn't exercise all the available commands or something like that when you did your capture. So there are some cons to that. There are some pros to that, and that is basically like if you don't understand this protocol and you don't have the time and the manpower to fully implement, which is that's me. I don't have the manpower as one person, right, to implement a fuzzer for every single protocol out there. So I needed something that would help expedite the process. Also, if a particular software vendor, has a way of, doing FTP or something like that that's not RFC compliant, you're going to notice that because you got a live capture, right? So you're actually going to be fuzzing as it really talks. So there's some pros and cons. And there's some things you can do to overcome some of those cons, and that's what I'm making my research on. I'm going to try and use genetic algorithms to find a way to like automatically kind of learn some more of that protocol that we didn't have in our capture and try to get better code coverages. I think I'm going to be a little late ending since I was pretty late starting. Okay. Okay, I'll try. I'll certainly try. So, yeah, so there's definitely pros and cons. There's also like fuzzing frameworks, which is like you can make calls to an API or something like that that help you write fuzzers fast. And there's old school random generators. I'll start moving through this hopefully kind of fast. There's test cases, which is like you have a list of tests. This is like how you create the semi-invalid data. You could do it cyclically, right, which is like insert every byte of what I replay, 1, 2, 3, 4, I insert 1 byte, 2 bytes, 3 bytes, 4 bytes of every possible byte or random bytes or whatever, and that's like an exponentially large sort of deal if you want to go up to like 100,000 bytes in every position. So you might not want to do that. You might want to kind of only use that in certain circumstances where maybe you're thinking there's an off by 1 or something like that in there. Random, again, is good. I like random in some ways, but it's pretty big runtime. There's library, like this is what AutoDefay uses, which is sort of like I have a list strings that have already determined are bad, they're like they try to hit certain boundaries, like maybe the first one is like size 3 and the next one's size 8 and the next one's size 16, 32, 31, 33. Those numbers might sound familiar to you guys, right? Like powers of 2 sort of increasing in sizes. Also, the obvious things like format bugs, and so they're going to use data that kind of makes sense, that kind of cuts down some of the runtime. Okay, this is the intelligent fuzzing thing. So again, if I say I write fuzzers, and the other guy says, I write intelligent fuzzers, you sort of think that the other guy's fuzzers are better, and that's not really what it means, and that's why I don't really like those words. All dumb and intelligent means is it's a measure of protocol knowledge, right? It's some measure of how well it understands the protocol. If you get too smart, you just fully implemented a server or a client. And it doesn't really do you any good, right? Because it's fully RFC compliant, it doesn't find bugs. And if you're too dumb, you're just only ever throwing completely random crap. You never advance deeper into the protocol except for the first layer. So if you only ever have a layer 1 protocol like maybe the command line arguments to LS, there's really only one layer to that protocol, if you will. So it's okay to like throw totally random crap at that. It might be better to not do completely random crap, like, if you know what the switches are, like -L, well, do a -L and then random crap, right? So you still want probably still want some ability to understand. You might want to do all random stuff last or first. I like to do it last because you do your smarter searching first, and if you don't find it, you sort of kind of open up the throttle, right, and just kind of let it go for a little longer. So which fuzzer's best? Nobody knows. There's no research, and it basically depends. I won't beat that to death. I'll blow right through context-free grammars. Context-free grammars are a way of describing something completely. Like you see there's like a transfer, and there's like transfer equals a read or a write. A read equals, a read request. A read request is a file name. A file name is a character. A character is like, so you have this complete of describing a protocol. This is how JaredDeMott writes their fuzzers. And based on that complete description, and then they can also like insert bugs or whatever, you can insert attacks in this description. So I won't really go through too much of that. One thing that Protos group, this is the Finland group, the secure programming group in the University of Oulu, that's where JaredDeMott came from. One thing that they said was really interesting, and it's not rocket scientists, but it's kind of like basic things that when you think about them in a certain way, they said that software bases could become immune to their tools. I just like that word. It was really kind of a cool term. It's basically like you run their tool against, say that they were checking BGP. They read BGP fuzzer, and they ran it against Cisco and Juniper. Cisco got a thumbs up, Juniper got a thumbs down, or vice versa, or whatever. I don't know. I'm just making this up. But you could use it as a thumb up, thumb down, but what happens is if it found 2 bugs, and so it was thumbs down, you fix those 2 bugs, you run it again, it's thumbs up, right? And that's a good That's the whole idea behind testing and being able to retest. But since there's no randomness in their tool, it's deterministic in the way it runs, it's good for QA, because you can run it again and see if you actually fixed the bugs you think you fixed. But it might not be so good in terms of the fact that those code bases, say, pretend their tool is the only tool out there and it like gets popular and that's the only one anybody ever uses to fuzz. Those code bases, especially if they're like open source, like OpenSSL, like components or something like that, they truly are immune to that tool. So you run it, it doesn't find anything. Does it mean that there's bugs or not, right? You don't really have confidence in that. So it's nice that there's a lot of tools out there starting to show up finally, like GPF, like AutoDefA, that you can go and download and you can write your own fuzzers and do all this stuff too, right? So this is just kind of talking about what I was talking about, what a generic fuzzer might do for you. Like the tool I wrote, it should be able to do some capturing and some replaying. You should be able to convert to a neutral format, which I do because you can't really edit PCAP files very easily. The demo I give talks about that. Tokenize, it'll talk about that. Strong attack heuristics. Intelligent randomness, right? You don't want it to, you want your error rate to be relatively low when you're replaying according to, you know, the functional protocol spec. One cool thing that is nice, and you're seeing more of this, is that's like dynamic information back from the target under test. You know, getting back data like, oh, I just crapped out. That'd be nice to know, tell the fuzzer, right? So he can stop and maybe log what he just sent, something like that. So there's some notion of data back from the target, which would be good. Really good, in fact. And distributed fuzzing was an idea I have. I don't think I've ever seen or heard of too many people doing this, but wouldn't it be cool if you wanted to fuzz some big process, you know, like IIS or something like that, that might take a long time to fuzz because it's going to be hard to fuzz because there's not many bugs in it. Gotcha. What if you like set it up on 100 machines, started your fuzzer on 100 machines, and had some central server that was kind of like, you know, divvied up the job, things you wanted to fuzz, and you just like open the floodgates, right? There's plenty of organizations that have the resources to do that. Okay, so I'm not one of them, by the way. So how is web and file fuzzing a little different? I just wanted to bring this up to show you that fuzzing is a little different depending on what you're fuzzing. Like for web auditing, I'm sure you guys have probably done a little, maybe there's some web auditors in here. The chance that you're going to like send bad HTTP GET requests to Apache or IIS right now and get it to crash, get the actual web server to crash, it could happen, but it's fairly low, right? What's more likely when you're editing or you're auditing websites is basically like, you know, some dude has some crappy MyBlogger site space, whatever, and a lot of these are written in like PHP and stuff like that. You know, maybe they're not real good. Anybody heard of file inclusion vulnerabilities in PHP scripts? So yeah, there's some people, yeah, you've heard of that. So it's going to be kind of hard to find that with just like a traditional client-server fuzzer kind of methodology. So, because what you actually need to look for is not the HTTP server to die, but what you're looking for is error codes, like the HTTP server sends back, you know, good, oh, bad. Oh, we need to, it's just sent back a bad. Maybe what I just sent wasn't good, you know, something like that. So it's a little bit different. File fuzzing is actually really similar. Sutton actually doesn't work for iDefense anymore, but they came up with, they kind of were kind of the first ones to really go big in public with file fuzzing. There's a lot of people doing it now. If you look at Pedrum's PyMay framework, there's actually a file fuzzer built into PyMay now. So the only reason it's different is just that there's not that network interface element. So how you deliver and how you monitor is a little bit different, particularly since like if you're, you know, fuzzing Word, you need to keep delivering bad Word documents to Word. So you need to keep starting Word, kind of like I talked about before, and you need some framework to be able to do that kind of work. And PyMay is actually a good framework to do that. Create a, you know, funky file, whether dumb or smart. Dumb would be like you just randomize the bits. Smart would be like you know the structure of Word documents, right? And you maybe just change one or something like that. So yeah, it's a little different, but it's actually really similar in terms of what it's doing. So fuzzing metrics, let's go through this. Martin Vegno that came up with AutoDefA is a good tool. He was the first to kind of do any sort of formal computer science study, I think, on metrics for fuzzing, which is good. And it's really not rocket science. It's actually really simple to understand. All he said was basically the number of substituted variables, which is like his library, L, of all. So he has 10,000 bad strings that he wants to fuzz with. And say like, you know, for user and pass and all these, he has maybe like, you know, whatever, 10 or 100 or whatever. You just times them together basically, and if it's like a second per transaction, you can actually get a metric on how long you think it's going to take to fuzz this particular server, which is a really useful thing to know, particularly for QA type people. They'd like to know how long is this going to take to run. And he actually went a step further, which is really cool. Since he debugged the target process, he can actually say, well, when you send user space Jared, the Jared is consumed by a stir copy. Well, that's interesting. That's better than just the user. So let's fuzz that first. So he orders his complexity. So you have an ordered complexity, which is, again, not rocket science in terms of what's done in computer science, but it's really cool stuff for this kind of field because there haven't been a lot of people to do kind of a formal study on fuzzing like that. So, and those are like some of the naughty functions out there that his thing actually looks for. So it's pretty cool. My thing is, like, I'd like to see people do. Some people are like, you should only use a list of strings because, like, sending random crap is irrelevant because, like, we already know the list of the heuristics and stuff like that. I'm like, nah, do that first if you want. And then, do some more randomness, randomize the position of where some random stuff might get in. Maybe you don't know, right? You tell your tool just to pick a spot. First leg, seventh leg, 10 legs deep in the protocol. Pick a position, pick some random data, you know what I mean? Do some of that. Add randomness, I like structured testing, but I like some randomness too. And the research I'm going to be doing this year, so maybe if it's successful and you all come to DEF CON next year, maybe I'll talk there. I'd like to use, again, genetic algorithms to try and have a fuzzer sort of learn where it's not working well. Maybe by using some code coverage metrics or something like that, have it be fuzzing and be like, oh, you know how evolutionary computing works. It's sort of like you have a generation, right, of parents, and it's sort of like when I sent, I got 8% code coverage. And that was the best of the group. All the other ones only got 3% code coverage. So maybe I should breed, those parents or something like that. And maybe now I get 9% code coverage. So it's sort of automatically learning the protocol and automatically being able to cover more of the binary. So you have to be able to monitor the process and send stuff back. And I don't know how to do this yet. I haven't been able to successfully do this or anything like that. I'm just now starting my research on it. So hopefully by like April or something, I'll be done with that. And that would be really cool. So I think I want to just go into the demo, and hopefully we'll have a few minutes for questions at the end. The demo is just a little video of, why do I have a lot of sessions of that up? That one's still up too. Really cool. Okay. Can you guys see that or hear that?
I'm going to demonstrate a tool I wrote called GPS.
Can't hear
Or
it?
acronym I was jokingly called the General Protection File. GPS actually stands for General Purpose Fuzzing. If you're not familiar with fuzzing or have never heard of the term, stay with me. Fuzzing is simply an automated testing technique used to discover implementation issues or bugs.
Can't hear it, can you?
Quality assurance folks
Well,
call this activity
basically,
negative testing. I intend to write a book on fuzzing
I'll tell you what I'll do.
to better explain the finer points.
I'll just turn the volume down on it up here,
Tell me download.
and I'll just kind of tell you what's going on. Basically, I'm just showing some of the uses of my tool there, and to start off with, I'll just basically send totally random crap at SSH, right? Just maybe a first test, because SSH is a little hard to fuzz right off the bat, right? Because it's an encrypted protocol. So if you really want to fuzz deep into SSH, you're going to know a little bit more about the protocol. For example, you're going to have to be able to do some cryptographic handshaking, right? So maybe you don't want to do that. Maybe you just want to say, hey, I'm just going to wing it. I'm screw that intelligent fuzzing. I'm just gonna blast off, right? I don't know if you can see that at all, but I'm just like typing, the IP address and stuff, and it just starts sending totally random packets, just totally random crap UDP packets at a target. And that's found bugs amazingly in the past, but it's not the greatest way to fuzz in the world, right? Because it's not all that. So, depending on the protocol, here I'm just going to show you how I took an FTP capture that I had created with Wireshark. I captured an FTP session, and I try to cap the file. Oh, man, that doesn't look too good. I better reset my terminal. And then I want to convert it to this middle format. I call it a .gpf file. Because suppose you want to fuzz when the username is valid, right? That's going to hit a certain code path. But suppose you want to fuzz when every time you say a name that's not valid, that might fuzz a different path, or when the password's valid or the password's not valid or something like that. So it's nice to have a way to be able to edit these files really quickly and just say, I have an idea for a test. What if I use a valid username and then I log out on the same line? I've actually found some really weird bugs like this where you do like a log out, but you don't do the /r/n. Just do like a /r instead of both, and then do like a login again or something like that. But all on the same line, because FTP expects like multiple commands on the same line, stuff like that. Found some bugs in IMAP doing stuff like that. You know, you can come up with various kinds of tests really easily like this, and actually there's ways that GPF can come up with those sort of tests for you on a more random basis. But if you have a targeted test, that's a really good way to do that. So you saw me edit that file, and I changed, you know, the username or something like that. Now when you cat it, like, you know, oh, that's actually just me. I actually have, like, in each one of these directories, I have like a -gr client.sh, because GPF, like, the list of arguments is like, I don't know, 16 arguments or something like that. It's a little gross. So I have like a whole bunch of I have just like little shell scripts in each directory so that you don't have to remember what all the various arguments might be. So that was just me like replaying a file. You saw like it said, okay, give me, like, I'm an FTP server, and I said, this is my username. He said, yeah, you're good, and then password. So just that same example that I talked about at the beginning, just again so that people can understand and see, this is how I could really fuzz something. It's really not that hard. I think sometimes people think about fuzz, think, I can't do that. That's only for like really smart people and vulnerability researchers and people that are going for a PhD, which I never thought I'd do because I'm not really that smart. But as we were talking about earlier, it's all about perseverance, right? Education, has anybody been through the educational system? It's more about perseverance than smarts. Is that true? Anybody say amen to that? I know I feel that way. So, but anyway, that was what I was just showing there. That was the side of an FTP session. So now I'm setting GPF to run as an FTP server instead of the client. And you see me with an FTP client in Windows. I'm clicking on try to connect to GPF, try to connect, click, try to connect, click, try to connect. And that's actually a really bad way to fuzz, right? Because you don't want to have to manually intervene when you're fuzzing. That's a terrible way to fuzz. But I showed it because it's funny. It actually worked. I actually found a bug in that FTP client. And I never reported that, I don't think. But yeah, don't download that software. I wouldn't download that software and use it as an FTP client. But anyway, what I really wanted to show you was that you could use PyMay to, I know I'm with you. Remember, I started like 20 minutes late beyond my capability and choices. So I'm trying to wrap it up. Where I think this demo has like 5 more minutes in it, and then we'll be done. So I forget what I'm trying to show here. Oh, just that GPF noticed, by the way, when that FTP client ended prematurely, it noticed, hey, I got a dead socket there. So it can kind of like give you some reporting that something bad happened when it was trying to send crap to that client. All right, here I'm just running GPF as a web server, because like our Mozilla guy up here up front, there's so many people doing web client browser fuzzing, i.e. Mozilla, whatever. That's kind of like gotten to be, that's just like the newest big rage, right? Because HD did his thing. So I was just showing you that you could start GPF as a web server if you want, and then I'll go over and I'll actually use, instead of, you know, opening up IE manually every time and clicking like that, it would be really painful. This time I actually do the right thing, and I use a framework. I just start a Python script, which I think I just called something like fuzzie.py or something like that. And all it really does is it just, like I said before, it starts IE, and I set IE to connect to the IP address that GPF's listening on as the default home page, right? So every time you open it, it goes right to there and tries to like connect. And then GPF starts sending all kinds of crap back to it, beating on it. And then if the browser hasn't died in like 10 seconds, I think is what I set it for, PyMay will close the browser and start a new one. So it's actually like really elegant. It's fairly simple, and it's really not that hard to do. So if you've got something you like to fuzz, your cable modem, IE, whatever, you can do that pretty easily with this tool, and I'm guarantee you'll find stuff, because I haven't limited the function. A lot of people, when they release a fuzzer, like what Martin did with AutoDefay, is he limited the functionality of his fuzzer. It's supposed to look for like, you know, 10, I forget what it is, like 80 naughty functions or something like that, and he only like has it look for 2 or something like that in the public release. I don't know why people do that, but I guess just part of what they need to do to get paid or something like that. So just kind of showing you that I didn't make the fuzzer for this HTTP session all that intelligent, just because I didn't want to actually show an IE bug up here on stage. But it works pretty well. So I think the next thing I'm going to be fuzzing, I can't remember what it is. We'll find out. second here. You're missing out on the music too, since you can't hear the music. I like kind of like, you know, talk through the whole thing and set some cool music in the background and stuff. But you can download it, appliedsec.com. Who can remember appliedsec.com? All my slides, all my papers, my tool, everything I've done is up there. Look for appliedsec.com/developers. You can download it all. It's all there, including the PyMay script that starts up IE like that. If you're not sure how to write that script, that's in there. So here I was just showing what a tokenizer file looks like. So say this is actually the tokenizer file that understands, like, basically for the most part all normal ASCII protocols that don't have some other sort of, you know, authentication or linked fields or something like that in them. And the point I wanted to make is that it's not really hard to write one of these. And then I'll show you the DNS one real quick, and then I'll actually fuzz. I started Winbind in a Win 2000 VM. I've got, you'll see that in a second. It'll come up. You'll see I got Winbind running in a VM, and I'll actually fuzz the bind server on that. And what's really sweet, this is a really cool way to fuzz, right? So the way I fuzzed Winbind was I set GPF up as a client using the same tokenizing file and the same capture and stuff like that, sending bad DNS requests to the server. Well, what does a DNS server do when it can't resolve a request that it gets? It tries to ask, like, its root server, the next guy up, right? So I also have GPF listening as a server, as the guy that he should talk to next. So when he says, I can't resolve this is crap, what do you think? I send him back more crap. So I'm actually, like, fuzzing both attack surfaces. It's pretty cool. It's very cool. It's very good stuff. I like that. I like how you can do that. So did I just do it? I wasn't watching. Oh, I screwed up the flags. So you can set your source port in GPF. I had to do that for TFTP. Does anybody know anything about the TFTP protocol? I heard somebody say, amen, that sucks. That protocol blows. You got to come in on, like, you have source ports need to be right, all this stuff. It's ugly. It is a really ugly protocol to fuzz. It's not normal. But GPF can fuzz TFTP. So yeah. So there, I think I'm actually fuzzing DNS. And I don't know if I scrolled up or not to show you how well it tokenizes. When you give it a tokenizing, like a little tokenizing plugin, before it starts fuzzing, it shows you, this is how I did, this is how I understand the protocol. The first 2 fields are a session, the second 2 bytes are a link, the second 2 bytes are whatever. Like, and that helps you know if the tokenizer you're either using or wrote is correct. Right, so, here's a fun one. This is pretty bad. The dude that wrote Dovecot said he'd give €1,000 to anybody who could find a bug in Dovecot. And I submitted like 5 bugs to him, like, I don't know, a year and a half ago or something like that. And I never got any euros, but what's funny, if you do yum install Dovecot on Fedora Core 4, it still has problems. So that was GPF finding a few SIG11s in the auth and login processes in Dovecot. So Dovecot is like POP3 IMAP type server. IMAP. Yeah, you can do POP3 too. You can do a whole bunch of crap with it. Actually, it's pretty cool. And in the newest releases, those bugs have been fixed, I think. But for some reason, when you do yum install Dovecot on Fedora Core 4, it still grabs like version .99 or 0.99 or something like that, because the latest ones aren't stable. So, what do I choose? No stability or no bugs? That's a tough one there. Yeah, it's bad. It's bad. So, and I actually used to find some of those bugs in Dovecot. I used what I call Super GPF, which is kind of an interesting idea I had, because, you know, GPF, you saw it had a lot of command line arguments, right? Like 16 of them or something like that. And it has different modes it can run in -P for the pattern matching, and -G, F for format, -GB for buffer overflow, like if you want to target what you're looking for and stuff like that. So I said to myself, I don't even know how is this guy right now. What if I write a Perl script that takes the capture file I had, I file fuzz it and create like 1,000 new capture files that weren't even real capture files, but they're cool because I mixed in valid commands that I never even saw. And then I randomly start GPF with switches that I'm just going to randomize all the command line arguments, basically, because I don't know how I want to fuzz it. And I just start all these instances of GPF just going nuts against Dovecot, and that's how I found some of those bugs, which incidentally ended up being kind of a pain in the butt to try and figure out why those bugs had occurred, because imagine you've got like 1,000 instances of a fuzzer in some process. It dies in a really weird, obscure way, and you can't really get good debugging information out of it. It can be kind of a pain to figure out why it died, right? And that's why part of that logging and monitoring the target process is important. So, all right, I don't think I have time for questions, but I'm going to go outside after this if anybody wants to talk to me. Thanks. There goes Mozilla, man. What's that? Phil, hi, how are you? Not a lot. I know Ari. I met him for dinner one time, and he wants to write a book with me on fuzzing. So since we kind of approach it differently and stuff, I thought that would be a good idea. I haven't yet been able to find time to kind of fit that into my schedule, and he hasn't found time for his either. But hopefully.